In the first step of two-step profit maximization, we derived the firm's marginal cost curve, and we now want to relate that to the firm's average cost. And we want to do that both in the long run and in the short run. Now in the long run, the firm is going to have three types of costs. The cost associated with labor, the cost associated with capital, and then the third cost we haven't mentioned yet, which we'll call a recurring fixed cost. A fixed cost you have to pay once in a while just to be in business. For example, a license fee is something you have to pay annually to stay in business, but it doesn't depend on how much you produce or whether you produce at all. If you're in business, you have to pay that license fee. Now, only one of these is a true economic cost in the short run. So in the short run, the only economic cost is the cost associated with labor, because it's the only thing we have control over in the short run. We've already committed to a fixed level of capital, and we have to pay for that regardless of how much we produce or whether we produce at all. And we've already paid for the license fee for the year, so we can't get that money back. So you still have expenses. The expenses associated with capital and recurring fixed costs. But they're not true economic costs in the short run. They're not opportunity costs of producing in the short run. And so they'll never show up in our short-run cost curves. They'll only show up in our long-run cost curves. So we derived a short-run marginal cost curve, and we said it might have a shape like this, a U shape. And that U shape arose from the fact that we assumed that it would initially get easier and easier to produce, because initially we have increasing marginal product of labor. With our fixed level of capital, each additional worker is adding more to my total production than the previous worker. But eventually the law of diminishing marginal product of labor kicks in, and so we have diminishing marginal product of labor. It's getting harder and harder to produce, so our marginal costs are going up. Now we could have a short-run production function that doesn't have this increasing marginal product of labor portion. In that case, we'd get a marginal cost curve that is upward sloping throughout, that doesn't have that U shape. So in that case, we would have decreasing marginal product of labor throughout, and we'd never have that portion where it's getting easier and easier to produce. What we can't have is a marginal cost curve in the short run that keeps falling, because that would be a violation of the law of diminishing marginal product of labor. In the long run, we got a similar shape. We said initially in the long run, it might get easier and easier to produce, so our marginal costs are going to fall, and eventually it gets harder and harder to produce. Only now we're not just changing one input. We're operating on a ray from the origin where we're changing labor and capital along that cost minimizing ray. And along that ray, we have an initially increasing returns to scale portion that turns eventually to decreasing returns to scale. So the U shape now emerges from the changing returns to scale along that cost minimizing ray. We could have a production process that doesn't have increasing returns to scale anywhere. In that case, we'd never get that downward sloping part of the long run marginal cost curve, and the marginal cost would be upward sloping throughout. So in that case, we have decreasing returns to scale throughout. Now it's also possible for a firm to have increasing returns to scale throughout, which would mean the marginal cost keeps falling. But that's inconsistent with a price-taking firm. A price-taking firm is small, and a firm that has increasing returns to scale throughout would become very large. So for now, we're just going to assume that our long-run marginal cost curves either take this shape or this shape. Now what about the average cost? Well, the average cost is equal to the total cost divided by output. That's just a definition. Now let's think about the average cost of producing the first unit of output in the short run. The marginal cost of that first unit is the additional cost we incur from producing 1 rather than 0 units. which is also equal to the total cost of that first unit. When we divide that total cost of the first unit by 1, because we're only producing 1 unit, we get the average cost. So for that first unit, the average cost and the total cost and the marginal cost are all the same. So the average cost would start at the same point as the marginal cost curve in both cases. Then, as it gets easier and easier to produce, the average cost will fall. And it will keep falling until it crosses the marginal cost curve. And then it reaches its lowest point. That's not an assumption. That has to logically be true. And to see that, think about grades. Suppose you accumulate a bunch of grades throughout the semester, so you go into the final exam with an average grade. If you want that average grade to rise from the next exam, the marginal exam, the final exam, it has to be that the final exam grade is above your average going into the final exam. That's the only way it can move up. If you want your final grade in the course to fall from the current average, then the final exam grade has to be below the current average to drag that average down. Well, it's the same thing with cost curves. The only way the average cost can increase is if the marginal cost lies above the average cost and drags it up. The only way it can decrease is if the marginal cost lies below the average cost and drags the average down. So that's why the average cost curve must cross the marginal cost curve at its lowest point. What about this case? The average cost starts at the same point as the marginal cost, but the marginal cost is increasing throughout. So it's pulling that average up from the first unit on, and we simply get an average cost curve that lies below the marginal cost, allowing the marginal cost to drag the average up, but we don't get that first part of the U-shape. What about the long run? Well, the same thing's going to hold in the long run, as long as we don't have recurring fixed costs. So suppose we ignore the recurring fixed cost. Then the marginal cost of the first unit is the total cost of the first unit, which then also becomes the average cost of the first unit. So the average cost starts at the same point as the marginal cost curve. Then the average cost falls as it's getting easier to produce, but eventually it's going to rise once it crosses the marginal cost curve, and then the marginal cost will drag the average up. Or in this case, the average cost is rising throughout, and the marginal cost is dragging it up by lying above it. So that's without fixed costs. In another class, you might have called this the average variable cost. If we include the recurring fixed cost, then the average cost doesn't start at the same point as the marginal cost, because it includes that additional fixed cost, which isn't part of marginal costs. So then the average cost would start above the marginal cost curve, but as it gets easier and easier to produce, it would fall. As it falls, it eventually reaches the marginal cost curve and will cross that, and then will be dragged up by the marginal costs. So this is the average cost with fixed costs. Now, notice that these two curves have to get closer and closer to each other, because the fixed cost on average will become a smaller and smaller part of total costs. If we're only producing one unit and we have $10,000 in fixed costs, then all of that would be part of this difference. But if we produce 2 units, then that $10,000 fixed cost is spread across 2 units, and so on average it's only $5,000. And so on. So these curves have to converge to each other as output increases. We can similarly put the average cost with fixed costs into this picture. It would start higher. For that first unit we have to add the fixed cost. But then as we produce more, that fixed cost becomes a smaller and smaller part of average costs. We get a downward sloping average cost curve. When it crosses the marginal cost, it's going to start to slope up. So we get an average cost with fixed costs. So we can now see that in the long run, the average cost curve might take on a U-shape for two different reasons. It could be that we don't have recurring fixed costs, but we simply have an increasing returns to scale part followed by a decreasing returns to scale part, which creates our U-shape. It initially gets easier and easier to produce, eventually becomes harder and harder to produce. Or it could be that we don't have an increasing returns to scale part of the production function, but we do have a recurring fixed cost, and that recurring fixed cost creates that U-shape despite the fact that we have decreasing returns to scale throughout. It'll turn out to be important that competitive price-taking firms have U-shaped long-run average cost curves. And so now we know that that U-shape can emerge for two different reasons.